Hi, this is Jay Weathers from the Deep Learning team. Okay, as promised, we're jumping into the breast cancer prediction model provided by AWS. Okay, so first I'm going to show you how to actually get to the notebook. Click on SageMaker. We have one instance in service. We actually deployed this instance in another video. You can go to the Getting Started with AWS SageMaker video to see that piece. We're going to open the notebook. Now that we've opened the notebook, click on Sample Notebooks, click on Introduction to Applying Machine Learning, and you'll see it right here, Breast Cancer Prediction. And this is the one we're going to actually start to work on. Okay, so here you can see Breast Cancer Prediction. So when we look at the background section, we're going to walk through these steps. We're going to do a basic setup for using SageMaker. We're going to convert a data set format using the AWS SageMaker algorithm and loading that to S3. We're going to train SageMaker linear learner model on the data set. We're going to host the trained model, and then we're going to score using the trained model. Then we move to setup. Specifying the ARN that we use for our S3 policy. And we want to use the S3 bucket. So the S3 bucket we're going to use. You go here, create a bucket. I'm going to call this demo bucket. Click next. Demo bucket 2018. Click next. Okay, we have our bucket. So we'll see here. Demo bucket 2018. We're going to copy that. I think I can remember that. Okay, so we created our bucket. Go back to breast cancer prediction. It says where it says your bucket name here. So remove those arrows also, those parameters. So the bucket name was demo bucket 2018. So that's our demo bucket. We're going to go ahead and run that cell. There's two ways to run a cell. The first way is to click run here, or on your PC you can click shift enter. First time I'll click shift enter. You can see the star. That means that it's actually importing and connecting to the bucket. When that star is finished, it will actually turn into a number. So that's how you'll know it's done. This is ran. We imported the Python libraries. Now we're coming here. This is the data that we're going to, and the data name is data.csv. So we're going to run this cell. Okay, this cell's running. That's completed, and you see it gives out a display of the data. Diagnosis, radius mean, texture mean, and other various data. So you'll see here data has 569 observations and 32 columns. We're going to split our data into 80% in the training, 10% into validation, and 10% for our testing data. I'm going to go ahead and run this field. Okay, great, that's done. Now we'll convert the data sets to record IO wrapped formats, and then upload this data to S3 so we can start training the data. So this is actually going to upload our data to S3. Okay, that's running. And now next we'll convert and upload the validation set. I'm going to go ahead and run this. Okay, great. After we run ECS, then we run the linear job role. Okay, so now it gives us a name for our linear job. From there, we can see that cell has run. Let's make sure. Okay, yep, that's ran. Okay, so now it gives us a name for our linear job. From there, we can see that cell has run. Let's make sure. Okay, yep, that's ran. It gives us our linear job number. Now we'll go ahead and kick off our training job. So we're going to run this cell. Okay, so now the job is training, and let me show you what that looks like in AWS SageMaker. you'll see that it says in progress, so it will show you your training job. Go to SageMaker. Let me click, refresh my screen, and you'll see that job is actually in progress. While that job's in progress, let's go back. We're going to move to the hosting of the actual algorithm. Once we've trained our linear algorithm on the data, we're going to set up a model that will host that data. What we'll do is point to a scoring container. It'll point to a model.tar.gz file that comes from the training, and then we'll create a hosting model. So let's go back and see if that model is still in progress. It'll say it here. It's still, the model's still running. We can check it here. Check the status of the model. Yep, still in progress. So previous models took about 7 minutes. I had one model take it about 11 minutes when I was doing the image classification. This one will take about 7 minutes. So we're going to go ahead and pause and then come back when this is completed. So now this job is actually wrapping up. If we go back to SageMaker, we click refresh, you'll see that that job status is now completed, and it took about 7 minutes. That had to replicate back to the Juniper notebook. Gives us a wait time of about 8 minutes. Now that we've trained our linear algorithm on our data, we're going to set up a model which can be hosted a little bit later. We're going to point to the scoring container, point to the model.tar.gz file that came from the training, and then we'll create a hosted model. We're going to go ahead and run this linear hosting container. Okay, great. This is our ARN for our linear hosting container. Once we've set up the model, we can configure our hosting endpoints. We're going to specify the EC2 instance type, the initial number of instances that we want, and our hosting model name. So here you'll see the M4 XL large as our instance type. Our initial number of instances is going to be 1, and our model name is going to be linear job, but you can change these to whatever best fits your use case. I'm going to go ahead and run the cell. Okay, great. Here's our endpoint configuration, ARN, and our linear endpoint config. So now that we've specified how our endpoint should be configured, we'll go ahead and create them. We'll do this in the background, and this will run a loop that updates on the status of the endpoints so we know when they're ready to use. So we'll go ahead and run this cell also. Okay, great. We've configured, now we're running, and the status is creating. So if you go back to SageMaker, I'm going to refresh my screen. We'll go to models. This is the model that we just created. Click on that. It just gives you information. You can add tags if you like. And let's look at our endpoint configurations. This is the endpoint configuration that we started with. And you can see it's allowing all traffic, and this is the instance type that we specified. Let's look at our jobs. Okay, great. Everything's looking good. We'll go back to our notebook. This is still creating. While that's creating, let's talk about what we're going to do to predict on our test data. We'll have our hosted endpoint. We'll generate statistical predictions from it. So now that the endpoint is hosted, we can actually generate statistical predictions from this data. We'll move to the function to convert an array to CSV. So it's this cell. We'll go ahead and run it. Awesome. Next, we'll invoke the endpoint to get predictions. Go ahead and run this cell. Next, we'll compare linear learner-based mean absolute prediction errors from a baseline prediction. Let's go ahead and run this cell. Okay, great. So our test made baseline is 0.552 and our test made linear is 0.228. Now AWS wants to compare predictive accuracy using a classification threshold of 0.5 for the predicted and compare against majority class prediction for the training data set. Let's go ahead and run this cell. Awesome. So we have a prediction accuracy of 87.9 and a baseline accuracy of 44.8%. This is the end of this model, and at the end you can actually clean up your AWS environment by deleting your endpoints once we're done. Now you can go ahead and read the extensions and get an even better accuracy rate. But right now I'm finished with this model, so I'm going to go ahead and delete the endpoints. As you can see, Amazon SageMaker is an absolutely amazing tool to build, train, and deploy machine learning models at scale, and I encourage you to just give it a try. Next steps, we encourage you to join our Slack channel if you're interested in learning about AWS SageMaker, deep learning in general. We want you to be a part of our team. We can win Kaggle competitions, you can meet great and dynamic people. So come on over to our Slack channel, and we look forward to doing great things with this new technology.